Hi friends, let me start this video by explaining what is a cell and what is EMF and its internal resistance. Now, cell is nothing but it's a device which offers you some constant potential difference so that you can use it to get some current. There is something called as EMF. EMF stands for electromotive force, but it's not a force actually. It is the maximum potential difference that a cell can offer to you. Say if this is your cell, the bigger line represents the positive end and the smaller line is for negative end. If this is connected across some resistance R, say, then the potential difference across these two ends will be E when R is infinity. I mean, when it is not connected to anything, then it will be E. Then why am I saying that it will be E only when R is infinity? So if R is not infinity, then what will be the case? If R is not infinity, the potential difference between these two ends will be slightly lesser because the material which is inside the cell offers some resistance to the current passing, and that resistance is nothing but this internal resistance. It is denoted by this small letter small r. So say if R is your internal resistance and you have some current I. Now what can I say from this circuit? I'll apply Ohm's law for this resistor capital R. I'll get V is equal to IR, right? So potential difference across these two ends is V. Now the same current comes here, right? Here there is a potential drop again when it crosses this small r. What is it? Capital I small r. And you have this potential gain of capital E across these two ends, say. Now E minus IR is equal to V. Is it clear for you? I'll explain you once again. Actually, this is the maximum potential difference that the cell can offer, but it is reduced by this amount because of internal resistance, and hence this is the potential difference that I can use for my bulb or any other electrical device. Hope everything is clear till. However, you can neglect this IR term, capital I small r term, when you have this E very greater than this capital I small r. Then you can neglect the internal resistance. Now let me tell you one more thing. You know that E minus IR is capital V, right? I can write capital V as capital I into R. So from this what can I say? Capital I is equal to E by R plus R. This will be the current in the circuit, and the maximum current will be E by R when this capital R becomes 0. I mean when you just connect the cell with a conductor which offers no resistance, then this will be my maximum current. Hope everything is clear till now. I have two cells which are connected in series. Both are different cells, and let their internal resistances be R1 and R2 and their EMFs be E1 and E2. Now we may get it out, why is this small r1 written to the right side of each cell? It doesn't matter even if you write to the left. It is just the resistance which is offered by the material which is inside the cell actually. So just to represent it, you just write it beside the cell. It doesn't matter where it is, to the right or left. Now I have this thing, I have this circuit. Say the current is I in the circuit. I want to calculate I want to find a cell which effectively replaces this both the cells. So I want to find a cell which has the EMF, effective EMF of both these cells together. Now the potential difference between these 2 points A and B will be E1 minus IR1 by the previous formula, and the potential difference between BC, that is V2, will be E2 minus IR2 from the previous formula. So my net potential difference between A and C will be V1 plus V2, right? and that will be this one, E1 plus E2 minus R of R1 plus R2, and the net potential difference should be equal to the effective or equivalent EMF minus equivalent internal resistance, right, of this cell I'm talking about. So from these two equations, what can you infer? You can just say that equivalent EMF is nothing but E1 plus E2, and the equivalent resistance, equivalent internal resistance is nothing but the algebraic sum. This is obvious because the cells are in series, the resistances are also in series. And let me tell you one more thing. What if my connection was something like this? You just observe this. I have reversed this. In this case, what happens is between A and B, the potential difference will be the same thing, E1 minus IR1. But between B and C, my potential difference here will be minus E2 minus IR1. Because I have reversed this, the EMF also gets reversed. Let me tell you one point. If the current is leaving through the negative electrode, then take the EMF of that cell to be negative. Okay. Now, so you understood that equivalent EMF of series combination of N cells will be just the sum of their individual EMFs, and it's the same case with internal resistances also. For this case, the effective EMF will be E1 minus E2, and the equivalent resistance obviously will be R1 plus R2. Okay. Now, this is the situation. I have two cells connected parallelly. Say these are my 2 points A and C, and these are my 2 points B1 and B2. If the current through this wire is I1 and current through this wire is I2, net current say I1 plus I2 is I. So I is equal to I1 plus I2. Now I want to replace this system, or I want to find an equivalent cell which replaces both these cells. So this should be my situation there. I should have E equivalent here and R equivalent here. Observe this. You know that I is equal to I1 plus I2. The potential difference between A and CB, V, which will be equal to E1 minus I1 R1 from the formula of potential difference when for a cell. And similarly for cell 2, it will be E2 minus I2 R2. Hope you understood this. Now from this formula, I can write that I1 is equal to V minus E1 by R1. Hope this is clear. Now I know that I is equal to I1 plus R1. So I'll replace these I terms with E and V and R terms. I can write this as E minus V by R, E effective or E equivalent. And I1 can be written as E1 minus V by R1, and I2 can be written as E2 minus V by R2. The same thing can be written as E1 by R1 plus E2 by R2 minus V of 1 by R1 plus 1 by R2, right? And the left side even you get EEQ by REQ minus V by REQ. So what can we infer from this? Comparing terms, you can say that EEQ by REQ is equal to E1 by R1 plus E2 by R2. So this will be the relation between equivalent EMF and equivalent resistance, equivalent internal resistance in terms of individual EMFs and resistances. Okay, this is the case when you have two cells, right? When n cells are connected parallelly, same thing. These terms get extended till n, Rn and En. Now you know the E1, E2 till En and R1, R2, but you don't know the Req, right? How will you get Req? From comparing these two terms, 1 by Req will be 1 by R1 plus 1 by R2. It's still 1 by Rn. Hope everything is clear till now. In the next video, I'll tell you Kirchhoff's rules and let's solve some really interesting problems. That's it for today. Bye, friends.